Hello everybody, welcome to Unit 2 of CS 219 Programming Fundamentals. And in this chapter we're going to cover a lot of core concepts involving data structures. So without further ado, let's go ahead and get started. So for the agenda today, we are going to cover ArrayLists, and specifically the ArrayList class in Java, and then also how to store primitives in them. And then we're going to look at some additional concepts involving array lists, such as for each loops and anonymous objects. And then we're going to go into linked lists, and specifically the linked list class in Java, and also how to measure execution time in your programs. Next, we'll look at queues and stacks, which are fundamental building blocks of computer science as far as abstract data types, and I'll talk about that and what they are and how to use them. And then finally, we'll look at the Java collection framework, which is how Java implements a lot of these data structures, and we'll look at specifically lists and maps. So let's go ahead and get started with the ArrayList class. The ArrayList class provides the basic functionality that comes with a standard array, plus it provides some additional functionality. So the basic functionality is that an array list stores an ordered collection of values and allows access to the values via an index, just like an array. So here, we can access, index at 0, we can access it at 1, and so on and so forth. But the added functionality is that with an array list, it can grow and shrink dynamically by inserting and deleting elements at a specified location, right? So here you could see that we inserted this 2b element right here at position 3, which caused everything else to shift down this way, right? We can't do that with an array. We can't dynamically grow our array. It takes a lot more work. So in addition to that, we can also delete things, right? We can delete them off the end, or if I wanted to, I could have deleted the 2b and shrunk the size of the array list. So it's pretty cool that we can do this stuff dynamically. The ArrayList class is defined in the Java API's java.util package. So for files that are going to use the ArrayList class, we import it like this. Now remember that if we are using other elements within the java.util package, we could just do .star to get everything inside the java.util package, or we can explicitly say .ArrayList to get just the ArrayList class. Now, to initialize an ArrayList reference variable in a declaration, we use this syntax right here, right? So we have the ArrayList type, and then we have a reference variable, that's going to be what you call it, followed by new ArrayList. So here's an example. So in this example, we have an ArrayList of type student called students, and then we are creating a new ArrayList to where the reference variable is going to point, right? So remember that this is a reference variable pointing to this new object that was just created in memory. So you're looking at this going, well, what the heck? What's the difference between these two, right? One of them has student and one of them doesn't. Well, you could do either way. So in this second example, you can see that we are omitting the second student. So the diamond operator right here is doing what we're calling inferencing. It's basically saying that, hey, we know from our declaration that our array list is going to be of type student. So we don't have to tell the compiler that we're going to create a new array of type student. It says, oh, okay, it's of type student, so I'll just build an array list that is of type student. So you want to make sure that you use the angled brackets to surround the type of the elements. And the biggest thing to note here is that it can't be a primitive. So I know what you might be thinking. What the heck is up with this angled bracket notation? The angled brackets denote the array class was built using a technique known as generics. And we won't get into them now. Just know that the generics allow you to pass in any type of reference object as a parameter. So you can see here in our array list, we're using student as our element type. But the array list could take any reference object that we could create. So let's go ahead and compare the syntaxes for creating array list objects, regular objects, and standard arrays. You can see here with the array list that we've already defined, we have the object, the reference object type in the angled brackets right here, right? And then it's basically students, new array list, whatever. So it looks very similar to this down here, right? Except for instead of the square braces, we use the angled brackets right there. And then with the regular object example, obviously we don't have any type of containing element like square brackets or diamonds, right? We're just declaring a singular object, okay? To add an element to the end of an array list object, we're going to use the following syntax, right? We have our name and then dot add item. Now, what's in the item must be the same type as what we declared to be the reference variable type to be. So if we had an array list of type student, right, then item here must be a student. Okay, we can't put in there a dog, or we can't put in there a car. We can only put in students. And if we try to do something else, we'll get a compile time error because the compiler is going to check that and say, hey, wait a minute, you're trying to put this different object type in this array list, and that's not going to fly. Now, there is an exception to that, and we will talk about that later in this section, and then later in later chapters. We'll get much more deeper into that. But don't worry about it for now. For now, just think to yourself, okay, it has to be the same type. So let's run through an example of using this ArrayList class. We're going to write code to create an array list to store names of well-known women in computer science. To do that, we must first declare our ArrayList reference variable and create an array list for it to point to, or reference. Once we have our ArrayList variable, we can add our computer scientists to our array list, like so. So here you can see we've declared our computer scientists, right, of type, it's an array list that holds type string. And then here you can see we just walk through and we're adding strings to each, to the computer scientists array list. Pretty simple, right? So we've seen how to add things to an array list, but how do we access them, or how do we get things out? Well, with standard arrays, you use square brackets to access and update an element, like this. Here we're getting whatever's in this integer array at position X, and we are, storing it in Y. Well, the array list object doesn't use square brackets. Instead, it has a get method to access an element and a set method to update an element. The index parameter here specifies the position of the desired element within the array list calling objects, right? So it is the same thing as this X right here, except for instead we use this .get method instead of the bracket notation. Now, as with standard arrays, the first element is at position 0 and the second element is at position 1, etc. and so forth, right? It's 0 index. If an index refers to a non-existent element, then a runtime error will occur. If an index is valid, then it'll return the element at the specified position. Now, note the E return type for the ArrayList get method. Right here, right? This E stands for element, and it represents the data type that is going to be stored within the array list. And so this E is the same thing that's the element type. So here you can see our syntax for our declaration of our array list. So whatever this E is going to, so in our previous example, we had student, right? Well, this E is really representing student or car or whatever, okay? It's just a placeholder. So when you're reading the API headings and you see this capital E like that, just note that it represents an element object. So this is how we update an array, right? So here we're storing a value at position X, and here's the ArrayList API for the set method. And you can see it's very similar to the get method, except for we pass in two parameters, right? We pass in the index and the element that we want to update. And of course, the index specifies the position that we're interested in. And the difference is that if the index refers to a non-existent element, then a runtime error occurs. If the index is valid, then we are going to then the set method assigns the element parameter to the specified element, overlaying what was there originally. So it's not inserting it, right? It's just overwriting it. So just like if there was something already in this array up top at position X, right, this 6 right here would overwrite what was ever stored in there. It doesn't add to it. And likewise with the set method, we're going to take this element E, and overwrite whatever is in this array list at position index. And again, E is just the element type, just like our student. So now that you get the general idea for the array list and the APIs, let's take a look at some additional methods that are available to you. We have add, where we can, this is kind of like an insert, we can add an element at the index, and whatever was there will be shifted down, right? So it's an insert function. We also have clear, which will remove all elements from the list. Then we also have the index of, which will search and find the first occurrence of the element in the array list. And if it's not found, it returns -1. And -1 is one of those things where it can be used as a sentinel value, right? So if you're working with a loop and you're using an array list, you can say while this position does not equal -1, and once it finds something that doesn't exist, you can kick out of the loop. So just trying to tie this in with last semester's discussion on sentinel values, right? We also have isEmpty, which will return true if it has no elements. And remove, which will remove the element from the index. And then also it will shift everything up 1, right? And then finally size. It'll return the number of elements in the list. Now remember that when we're working with an array, like say we have int array, right? To get the size of an int array, we just use .length. Note here that we actually have a size method and we have to use the parentheses after it. Similar to if we had a string, we're going to call it myString, right? myString. If we want to find out how long it is, we have to use myString.length with parentheses because it's a method and not a property, where with an array, the length is a property. So just keep that in mind. All right, exercise time. So knowing what you know about APIs for the ArrayList class, I want you to create an array list of strings to store your favorite movies. To do that, I want you to create your reference variable and the appropriate ArrayList object for it to point to. Then I want you to add 4 of your favorite movies. And I want you to remove the third one because, well, it's not really your favorite movie. And then I want you to print your favorite movie, okay, whichever one it is. So I'll wait here. Go ahead, pause the video, break out TextPad, and get to work. Okay, hopefully you actually did the work. If not, again, shame on you. You should have gotten something that looks like this. Here we are creating an array list of strings called Fave Movies, and we are using the this notation right here where we are not specifying that we're using a string, right? We're not inferencing it. And then so I added Empire Strikes Back, Office Space, The Notebook, and Planes, Trains, and Automobiles. Clearly, The Notebook is not my favorite movie, so we are going to remove it. Right? Notice that it's the third one in the list, so I have to use an index of 2. And then I just print my favorite movie is, of course, Empire Strikes Back, because it is awesome. And if you don't think so, well, I don't like you. Okay, so let's take a look at an example program. Here we have the Hunger Games by the author of the book. And we have our main method, and we have an integer called deceased index and a string called deceased, and then we are creating an array list of strings called tributes. And here's where we specify using the inference operator, right, using our angle brackets. And then here we are adding 4 tributes. So Cato or Cato, I forget, I haven't seen the movie in a while. Katniss, Peeta, Rue. And here we are adding Finnick, but we're adding it at position 1, right? So if we don't specify the position, we are just adding it at the end. But if we specify a position, then we are going to add in Finnick, and it's going to move everything down, right? So we've got 1, 2, 3, 4, 5 tributes that we've added. Then we are randomly picking one using our random math.random function or method. And we all remember how that works, right? Math.random returns a decimal from 0 to 0.999, right? And then we are multiplying it by the size of the tributes. Well, dot size for tributes is going to be 1, 2, 3, 4, 5, right? So that's going to give us an integer from 0 to 4, right? Because we're going to have point whatever to 4.99999. And if we cast that as an integer, remember it doesn't round, it's just going to truncate it, or basically use a floor operator. So we're going to get 0 to 4. So then we remove the index from tributes, and remember, remove actually returns the object that we're removing. So we can store that in deceased, right? And then we print out whoever it is, and then we print out the remaining tributes. So let's go ahead and take a look at this running. All right, it compiles, and you can see here Cato is no longer in the game, and the remaining people are Finnick, Katniss, Peeta, and Rue. All right, well, that's pretty cool. Now, one thing I want to point out here is this line right here. Okay, system.out print line remaining plus tributes. Well, tributes is an array list. Wait a minute, it's not a string. What's going on there? Well, tributes is storing objects that are of the string type. And so obviously you can print out a string, right? The cool thing about the array list is that it will automatically put whatever its contents in this array notation. So if you concatenate it with a string, it will give you the brackets in a comma separated list of values. But in order to do that, the objects inside of it have to have a toString method. Okay, so let's take a look at another example. We're going to call this Hunger Games bear, and we're going to use the bear as a different type of object. And notice that we have 2 variables here called maker and type, and we have a constructor called bear, right? And it's, of course, got a maker and a type, and we set it. Okay. Notice that there's no toString method here. We have a display, which is going to print out something, the maker plus the type, and so on and so forth, right? But we don't have a toString method. Okay, so I went ahead and modified the program to use bears instead of people, right? Now watch what happens when we run the program. All right, it compiles successfully, and here we go. Bear at 6D06D69C is no longer in the game, remaining bear at 7852E922. Okay, I believe we're going to talk about this later in the semester, but I want to point it out that it's kind of cool. This is actually kind of showing you a unique ID for the object. And so when you're comparing 2 objects using the equal operator, this is actually what's getting compared. Bear at here and bear at here. And so you're not getting the nice clean string that you would expect. So what happens if we actually add a toString function, right? So if I say public string toString, right? And we're just going to return we're going to return the maker, right? Return actually maker plus, and then the type, right? And it helps if I use the right constant. Let's take this for a test drive and see what happens. So we got to compile it. Oh, what I forget? Reach into file. Oh, yep, sure enough. See, even I make mistakes once in a while. All right, compile it successfully. Now let's go ahead and run Hunger Games again. And look at that. Bob Brown is no longer in the game, remaining Corey Black, Nicole Panda, right? Because we have Corey and Black, Bob and Brown, and Nicole and Panda. So you see how it automatically took this toString and used it when we print out the array list. So if you have an object, you can give it a toString method, and that will be used in a lot of different places. So when you're constructing your own objects, it's a really good idea to think about using the toString method. So I might be getting ahead. I think we use it later on in the semester, but I just wanted to kind of point this out there because it was in the code. So hopefully you got a good understanding of that now. So as mentioned previously, ArrayLists store reference variables, not primitives. So for example, in the Hunger Games program, tribute is an array of strings, right? And strings are reference types. But if you need to store primitives in an array list, you can't do it directly. So trying to do ArrayList of int will not work. However, you can do it if the primitives are wrapped in a wrapper class. And ever since Java 5.0, the wrapping process has been done behind the scenes. Okay? So for ArrayLists, it's done automatically if a wrapper class is used in an ArrayList declaration. So you can do this, but note here that we are using the wrapper class, not the primitive, right? So let's take a look at this in action. The stock average program here reads int stock values and stores them in an array list. And after all the stocks are entered, the program calculates the average stock value. Why is an array list appropriate for calculating a stock average? Well, think about it, right? It's very easy to go through and add them all up and do an average, right? It's a great container for that. So here we can see we're using the double wrapper class and adding items in using a double. So we've got double stock sum, and we're entering a stock value, and while stock is not, or while it's greater than 0, we're going to add a stock, right? And so we're going to enter the value, and it's going to keep going until we're done, and then we're going to do some other work, right? Notice here that this must be the wrapper class, okay, not a primitive. Also notice here that the auto boxing takes place, right? So stock is a double. We're not using capital D double. We're not using this, right? No, we're using this. So what's happening is Java compiler is saying, okay, stock stores the wrapper class, and I'm getting a primitive value, so go ahead and cast this primitive as the wrapper class, and that's what auto boxing does. And here's the rest of the code where it's actually going to go through and add them all up and divide by 0, right? So can you spot where the auto boxing happens in this section of code? And I'll go ahead and give you 10 seconds to take a look. All right, time's up. Stocks.getI is going to return a double wrapper class, right? It's going to return the stock as the capital D double, not the lowercase d double, but it's automatically converting it to an integer for this assignment operator. So that's kind of cool.